Hey guys, here's the Spiral Review for Spiral 18. I'm going to try to get through this one quickly. Got about 12 minutes until the next period begins. I'm hopefully going to get this done before that happens. First up, we've got to create some graphs based on radical equations. I'm going to make a quick table for some domain. And by domain, I mean some points. I'm going to start with -4, because that makes the inside of my radical 0. And 0 plus 1 would be 1, okay? The next good number to get on the inside would be +1. It's square root, so I can't have a negative. To get +1 on the inside, that's -3. -3, and if I plug that in, we get 4 is 1. Square root is 1. -1 plus 1 is 0. All right, the next nice number is 4. That means we're looking at 0. If I plug in 0, we get 4 square root is 2. -2 plus 1 is going to be -1. Next good number to get is going to be 9. And if I plug in a 5, I get 9. Okay? Negative square root of 9 is going to be -3. Plus 1 is -2. So we're looking at -4, comma 1. 1, 2, 3, 4, 1. -3, 0. 0, -1, and 5, -2. My graph starts here and goes down like this. My domain is going to be all numbers that are greater than or equal to -4. That's where my graph starts. My range is going to be all numbers that are less than +1, because that's where my graph starts, and I go down from there. For number 2, we're going to do the same thing, xy table. X is going to be 3 for my center point. So 3 minus 3 is 0. Okay, so cube root 0 times -2, 0. Plus 2 is 2. Going up 1 and down 1 from there, we get -2 when we got, +2 when we got 4. So if we got 2, we're looking at -1 times -2 is going to be +2 plus 2 is 4. And 4 minus 3 is 1. -2 plus 2 is 0. I'm going to go up and down. To make the inside -8, I need -5. And to make the inside +8, I need 11. Okay? So we've got -5 minus 3 is -8. Cube root is -2 times -2 is 4. Plus 2 is 6. And going the other way, we're looking at... There should be a 4 there. I was a little bit confused of why that looked that way. 4, that's 11 minus 3 is 8. Cube root is 2 minus 4 plus 2 would be -2. So we got 11, -2. We got 4, 0. We've got 3, 2. We've got 2, 4. And we've got -5 and 6. My graph is going to look something like this. And if I could hit the points, that'd be lovely. You can get a point for shape. You can get some points for those points. And then you're going to identify the domain and the range, both of which are all real numbers, because this is a cube root function. Solving the equations. Oh no, a fractional exponent. Whatever do I do? A nice thing to do might be to rewrite this as a square root instead, so that we don't get our brains confused. Okay, I'm going to -3 to both sides. I've got to get the square root by itself first. So we get 8 is equal to 2 times the square root of 3x minus 5. Divide by 2, and I get 3x minus 5 inside of a square root is equal to 4. I'm going to square both sides. I get 3x minus 5 is equal to 16. Add 5, divide by 3, and I get x equals 7. If I were to plug that back in, 2 square roots of 21 minus 5 plus 3. 21 minus 5 is 16. 2 times 4 is going to be 8 plus 3 is 11. This solution is not extraneous, and it works. Same thing over here. I'm going to get the cube root by itself first. We're going to add 4 to both sides. We get -6, and on the left we're going to have -2 cube roots x plus 5 divided by -2. We get the cube root of x plus 5 is equal to +3. Cube both sides 27 and x plus 5. Minus 5 to both sides, we get x equals 22. Negative 2 cube roots of 22 plus 5 is 27. Minus 4 equals negative 10. That's going to be 3 on the inside. Negative 2 times 3 is going to be negative 6. Minus 4 is indeed negative 10. Here we've got to graph some rational equations. I'm going to start off by finding my important points. We've got vertical asymptote, and in this case it's going to be whatever makes the bottom, the denominator, equal 0. And that's going to be at x equals 1/3. I'm going to have a horizontal asymptote, and I'm going to look at my leading coefficients. In this case, we also get 1/3. I'm going to find an x-intercept. There's nothing to factor here, so we're not going to have any holes. And when I find my x-intercept, I'm going to make the top equal to 0. We get x plus 3 is equal to 0, which means that x equals negative 3. So I'm going to put a point there. And to find my y-intercept, I'm going to do the same thing but plug in 0 for x. And when I do that, we get 0 plus 3 is 3 over 0 minus 1 is negative 1. We get y equals negative 3. That's somewhere down here. Shape of the curve, first half is going to look like that. Second half, if you'd like to make the assumption that it's up here, you'd be fine. You get full credit for that. If instead you'd like to check that point, you're welcome to do that as well. You can plug in a point to get that value. For number 6, this one looks a little bit different. And this one, in this form, you might remember that this ends up being our horizontal asymptote. We have to do a little bit more work for the rest of the stuff involved in this. But I'm going to start in the same way. So vertical asymptote, we get x plus 1 is equal to 0, which means x equals negative 1. For the horizontal asymptote, we're going to look at that number at the end, and negative 3 is equal to y. That moves my normal graph down 3. I'm going to label those just to make sure I can see that. For x-intercept, I'm going to make my y equal to 0. So 0 is equal to 2 over x plus 1 minus 3. I'm going to add 3 to both sides and multiply by x plus 1. We get 3x plus 3 is equal to 2. Minus 3, and then divide by 1, I get x equals negative 1/3. So that's an x-intercept, negative 1/3. Let's find a y-intercept by plugging in 0 for x. So y-int is going to be 2 over 0 plus 1 is 1, minus 3. 2 minus 3 is negative 1. And that's going to be down here above the horizontal asymptote. Which makes sense because that fits this curve, and you might realize the other half would be down here. If you'd like to plug in a point that's below negative 1, that would be fine too. Moving on to some variation problems. We have something with a number of cookies. This problem is related to the question that you can ask Siri if you want to find out what happens if you divide by 0. But the number of cookies that you get is inversely related to the number of friends that you have. So I'm going to call cookie C and friends F. I could say that C is equal to some constant K over the number of friends. That's an inverse relationship. If you have 4 friends, you get 50 cookies. So 50 cookies is equal to some constant K. Divide by 4. That means that K is 200. I'm going to use this information to figure out what happens if I have 50 friends. So C is equal to, instead of K, I'm going to use 200. And 50 is friends, C is equal to 4. So if I have 50 friends, I only get 4 cookies. For number 8, Z is jointly related to X and Y. Okay, I'm going to write that as Z is equal to some constant. Everything has a constant multiplied by both X and Y. When X is 7, Y is 12, and Z is 100. So we get 100 is equal to K times 7 times 12. In other words, 100 over 84 is equal to k. About the only thing I can do is divide this by 4, but I'm just going to leave it like that for now. Because then we'd like to know what happens if x is something and y is something. So we get z is equal to 100 over 84 multiplied by x is 4 and y is 8. So in this case, whatever this comes out to be, and that would be 3,200 over 84, which if you divide everything by 4, you get 800 over 21. I think that's about as far as you can go. Next up, we got some simplifying rational expressions. In other words, we have a lot of factoring to do. 2x squared minus 8x minus 90, I'm going to rewrite as 2 times the quantity x squared minus 4x minus 45, and that's going to factor into x minus 9 and x plus 5. The bottom of this, I'm going to do this in red, factors into x minus 9 and x plus 4. I need to indicate my domain at this point, so x minus 9 and x plus 4. My domain is x cannot equal 9 and x cannot equal negative 4. My x minus 9's cancel out, and I'm left with 2 times the quantity x plus 5 over x plus 4. For number 10, we're going to start again by factoring. On the top is going to factor into x plus 8 and x minus 6. The bottom is going to factor into 3 times x squared minus 36. I can go further in the bottom, so that'd be x plus 8, x minus 6, 3 times x plus 6, x minus 6. At this point, I'm going to do my domain. X cannot equal negative 6, and x cannot equal positive 6. Again, you need to include that when you're working with these functions. My x minus 6's cancel out, and my final answer is x plus 8 over 3 times the quantity x plus 6, such that x cannot equal negative 6 or positive 6. For number 11, we're doing some multiplying. And again, to begin this process, we're going to factor. 88 is going to be 8 and 11, so it's going to be x minus 11 and x plus 8. The bottom of that, I can be divided everything by 2. So that's looking at x squared plus 1x and then minus 132. On top, everything here is divisible by 4. So that'd be 4. Then x squared plus 14. X plus 33. And then the bottom of this is going to be x plus 8 and x minus 8. Okay, I'm going to carry down my x minus 11, x plus 8. I'm going to carry down my x plus 8, x minus 8. This guy's going to factor. And this was plus minus, so that'll be 2. And that factors into x plus 12, x minus 11. And up top, 33 is going to be 11 and 3. So we get 4x plus 11 and x plus 3. At this point, I need to do my domain. X cannot be negative 12, positive 11, negative 8, or positive 8. All 4 of those numbers would make me divide by 0. And then I can do some reducing. My 8 minus 11, x minus 11's cancel out. x plus 8's cancel out, and I can reduce 4 and 2 to just 2. And I'm left with 2 times the quantity x plus 11, x plus 3, over x plus 12 times x minus 8. I do not have to multiply this out. I can end here. For number 12, we've got a division. That means that as I set up my factoring step, I'm going to be flipping this term just so that we're aware of it. Okay. 4x squared minus 19x plus 12. So I'm looking for things that multiply to 16 and end up adding up, multiply to 48 and add up to negative 19. That's going to be negative 16 and negative 3. That's going to turn out into 4x squared. And by that I mean 4x minus 3. And then we're going to have x minus 4. The bottom's going to be x minus 4. Again, I'm going to flip this as I set this up. So the 4x minus 3 is going to be on the bottom. And the top of this should be x minus 4 and x minus 8. I am actually being a bad mathematician right now. I should have done that here. X minus 4 and x minus 8, because I have to consider this as the denominator for the domain. And if either of these numbers equal 0, that would cause the denominator of this fraction to be 0, which we can't do either. So x cannot equal 4. X cannot equal 8. That's from up here. X cannot equal, we already did 4, and then x cannot equal 3/4. And that's for that guy. Okay, now that I have reduced, I'm going to see what I can do. Found the domain. I'm going to see what I can reduce. 4x minus 3, 4x minus 3, x minus 4, x minus 4. We end up getting x minus 4 times x minus 8, such that x cannot equal any of these values. In solving a rational equation, just like as though we were adding or subtracting, we're going to have to get things as a common denominator. So I'm going to see what I can do here. I know this guy is really 1 over 1. This one is 2 over x, and this one is negative 3 over 4. I'm going to write this as x times x, just so that I can keep track of what's going on here. So all three pieces here need common denominator of 4xx. I chose this one because this is the biggest one, and it contains pieces of everything else. So to get my 1 over 1, I need all three pieces. I need 4 times x times x. And I've got to do that on the top and the bottom. To get 2 over x to that, I need a 4, and I need another x. Multiplying these all out, we'd get 4x squared over 4x squared plus 4 times 2 times x is going to be 8x. And on the bottom, we're going to have 4x squared. Negative 3 over 4x squared. At this point, I'm going to identify my domain. X cannot be 0, because if 0 is used, we get 0 in the denominator, and we cannot do that. We talked a couple different ways about this. One is that as soon as you have all the denominators the same, the only way for that to be true is if the numerators on each side were equal to each other. So from that, you could write this as 4x squared plus 8x equals negative 3. You could also say, okay, I'm going to multiply 4x squared by all three of these, and as I distribute that to all pieces, all three denominators cancel out, leaving me with the same result. In setting this up, this looks factorable. I'm going to do some magic and plus 3 to both sides. That's going to be 12, so this is going to be 6 and 2 to get 8. We end up getting 2x plus 3 and 2x plus 1 as my two factors. I'm just going to double check that. 4x squared, 3. We get 6x and 2x is 8x. Perfect. And that means that we get x values of -3/2 and -1/2. Neither of those violate our domain, so we're in good shape. For number 16, we're looking to do the same thing. I'm going to start off by factoring everything, and I'll probably write this first one as 2 over 1 just to make sure I realize it's a fraction. X squared minus 1 factors into x plus 1, x minus 1. Pro tip, I'm going to leave some space here, just so if I have to multiply I can. Then we get x over x minus 1. Again, I'm leaving lots of space around these things so I can build my common denominators around my original line. Okay, I've got x minus 1, x minus 1. This one needs an x minus 1. Okay, nothing else that the other ones don't have from the left. Okay, but here we've got an x plus 1. This one doesn't have x plus 1. This one does. This one does not. All right, and again, we can think about this one of two ways. The first is that now the denominators are all equal. The only way this works is if the numerators are equal as well. We could also think about this in terms of the idea that if I multiply by the entire denominator, it's going to clear them all at the same time. I also need to make sure I do my domain before I do anything else. X cannot equal 1 or -1. Okay, so in multiplying this through, if I distribute this back out, by the way, that's going to give me x squared minus 1 times 2. That would be 2x squared minus 2 equals nothing there, so we get just 4. And I made another not-so-good math move and didn't write that on the top and the bottom. And here we've got x squared plus 1x. I'm going to group everything onto the same side, and we get 2x squared minus 1x squared is going to be 1x squared. I'm going to have a minus 6 when I bring that 4 over, and a minus 1x. When factored, this is x minus 3 and x plus 2. This is still equal to 0, which means that x equals 3 or x equals -2, neither of which violate my domain, so I'm okay. Finally, number 17, we've got 3 over 1 is equal to 16x over, that's going to be x minus 1 and x minus 3. My domain, I'm just going to clear this guy out of the way. X cannot equal 1 or 3. Okay, let's build my rational function. This needs both pieces. We only have two fractions here. That's kind of nice. So this has to be 3 x minus 1, x minus 3 over x minus 1, x minus 3. And on the right side, we're going to have 16x over x minus 1, x minus 3. Denominators are the same. I can either just get rid of them, cross them right out, and that's really done by multiplying by both of them. So that would be x minus 1, x minus 3. By the entire equation, that causes those to cancel out. We're left with 3 times that is equal to 16x. Again, I'd like to remind us that we've already figured out what that is. So if I want to distribute the 3, I can just use that. 3x squared minus 12x plus 9, because that's 3 times x squared, minus 4x plus 3, is equal to 16x. I'm going to bring everything onto one side. And we get 3x squared minus 28x is equal to 9. 3 times 9 is, plus 9 is equal to 0. 3 times 9 is 27. 27 and 1 add up to 28, so it's going to be -27 and -1. And that's going to give me 3x minus 1. And for the other part, we're going to have minus 9 and x just to make sure. 3x times x is 3x squared. 3x times 9 negative is minus 27, minus 28. And negative 1 times negative 9 is positive 9. So x cannot, or x equals 1/3, and x equals 9. Neither of those touch the domain, so neither of those is extraneous.